Let's look at this question. When we solve Newton's law questions, there are steps to solve the question. One of the first things you must do is to draw the free body diagram. That is after data. You need the data. You need to be used to write the data, because you need to know what you have and what you've been asked for in order for you to select different formulas and different laws. All right. Second, you do need to draw the free body diagram, and if possible with the axis. Okay. This question say a force of 200 Newton. It is in the picture. I don't have to write the data. It's there. Acting at 60 degrees to the horizontal, accelerates a block of mass 50 kilograms along a horizontal plane as shown. Calculate the components, but before that one I said we must try to do the free body diagram. So let's begin by drawing the free body diagram. Maybe we can do it here on this side. Okay. As that one, I'm going to add the axis. This is no for marks. If you have to answer or draw a free body diagram for marks, then do not add the axis. You only add the axis if there is for you to work. Okay, like this one I'm doing. So here is my axis, and then I'm going to draw all the forces acting on that block in here. The block is in the center. So what forces are acting there? First of all, you know there is for sure normal force. All right. Solve that the force that the surface exerts on the object that is in contact with and is acting perpendicular to the surface. This one is normal. What else? There is frictional force. There is frictional force. They calculate the magnitude of the frictional force by question 2.2. So there is frictional force. What other force is acting here? There is weight pointing straight down, and there is another force, which is the acting or applied force. You can see they're making an angle of 60 degrees to the horizontal. That force is going to be from the object going all the way down like this. This one is the applied force. Is that understood? That force have an angle of 30 degrees to the horizontal, which in this case will be this angle here is 60 degrees. It's given to you. That force needs or has components, and I'm going to draw the components. If you come here to the x-axis, you have here the x component, applied force in x. I know it can be called horizontal component, it's fine. And then here, if you go to the y, you have the vertical component. This one is the applied force in the y-axis. You can move it also here if you think you're going to get confused, and that will be like a triangle now. All right, so those are the forces acting on that block. The components are not a force, they are components of a force. All right? But if the force is in none of the axes, when you find the components, it will be like this. Now, let's go to the question. Now we have the free body diagram, we can go to the question now. The question said, the first part of the question, calculate the components of the 200 Newton force that accelerates the block horizontally. In other words, they are asking you to calculate the applied force in x. Do you understand? The applied force in x, guys, is this one here. That one is the applied force in x. And you can see it's adjacent to the 60 degrees. So you have to use cos of theta. You know that, I'm going to do it here. Cos of theta is equal to adjacent side divided by hypotenuse. That is mathematics. It's going to be that side that is near to the angle. Okay? If you substitute here, you have cos of 60 degrees is equal to adjacent side is applied force in x. That is the adjacent to the angle. And the hypotenuse is going to be the applied force. If you rearrange this one, you have that the applied force in x is equal to applied force multiplied by cosine of 60 degrees. So here, you just substitute, you have everything. In the data is everything. Applied force in X is equal to 200 multiplied by cosine of 60 degrees. Why are we calculating that one? Because the question says calculate the component of the 200 Newton. You have two components, X and Y, that accelerate the block horizontally. Therefore, is the horizontal component. That is why we are calculating that one. This one will be question A, or what we use here for numbering, 2.1. Question 2.1. Write it here. The next question say calculate if the acceleration of the block is 1,5 meters per second square. So a part of the data here, now I know that the acceleration is equal to 1,5 meters per second square and is in that direction. You can see it in the picture there. All right. Calculate the magnitude of the frictional force on the block. Now that one is where I'm going to use this free body diagram. The object is moving horizontally. So I am going to work with the forces that are horizontally in this specific question or situation. So I'm going to work with these forces that are acting here. And I'm going to apply Newton's second law in that specific axis. So I'm coming here. Is F net equals to MA. I'm going to work in X axis. And I'm going to write positive. Okay, so what forces we have on the axis, on the X axis? We have the applied force in X, no applied force. Applied force is not on the axis, it's in between. So it's applied force in X minus friction, and that is equal to MA. Now you can substitute here. All right, the applied force in X, we did calculate it. It is 100. The frictional force, we're looking for friction. That is what we're looking for. So minus friction equal to the mass is given to us and it's 50 kilogram. I'm not going to write the unit. Multiplied by the acceleration, which is 1,5. Is that understood? Now you are going to move. This one is just rearranging the equation. Is minus frictional force is equal to, so you get 75. 75 minus 100. Is that correct? So we get here that frictional force is equal to minus how much? 25 Newton. The magnitude of the frictional force here is going to be equal to 25 Newton. Now we are going to, this one is question 2.2. Let's write it here. 2.2. Let's go on to question 2.3. Question 2.3, they say calculate the normal force. Now we go back to the free body diagram and we are going to go to the y-axis. Why the y-axis? Because the normal force is in y. Alright, so you come there, I'm going to mark. So I know I'm working with this axis here. So what forces do I have there? I have normal, I have the applied force in y, and I have weight. So those are the forces I'm going to use. I am going to apply Newton's first law of motion. Why Newton's first law of motion? Because the object is not moving in the y-axis. So I'm going to say F net is equal to 0. I'm going to work in y. You can write actually at the beginning here like in, like here, in y axis. And you can say up is positive. For example, F net is equal to 0. You have normal is positive, minus weight, minus applied force in the y-axis is equal to 0. When you rearrange, you get that normal is equal to weight plus applied force in the y-axis. Do you have weight? You don't have weight. We have to get weight. Do you have the applied force in the y-axis? You don't have the applied force in the y-axis. You do have to get it. Alright? How do you get weight? Weight is equal to mg. So if you want, you can calculate it separated like this. It's entirely up to you. Let's fix here so you can see. This one is the mass was how much? 50. The acceleration is 9,8. How much you get for weight? I told you, 490. That is the weight. We still have to get the applied force in y. We're coming back all the way here up to this point. You see, now we're looking for the opposite side to the angle. You can see that that one here is the opposite side to the angle. And you know that sine theta is equal to opposite side over hypotenuse. Which one is the opposite side? The applied force in the y-axis. Which one is the hypotenuse? The applied force. If you substitute here, rearrange, the applied force in y is equal to applied force multiplied by sine 60 degree. If you substitute, you will get that this one is 200 sine 60 degree 173.21 Newton. Now we have that one. We come back down and we substitute the numbers here. We go here, there we go. We are going to substitute what we have here. Weight is equal to 490 plus applied force in y 173.21. What is the normal force? 663.21 Newton. We are done.